Okay, so in this one we're looking at developing the solution. So what you're doing here is that you would take your plan and you would develop your solution. So you would have your title, and as you're going to go through, develop a solution. Remember, in this section you're going to include things like your design of garden area, this, and be like, well, it's, sorry, I didn't know if my computer died then. You would go, the first thing I did, or in order to complete this task, the garden area was designed. See figure 1. And now you might not necessarily have figure 1, but then you would attach that sheet with your design on it into your task. Then you would have the area of those things were calculated, and then you would have your either table of values where you've done calculations, or you might have one example and then have like it all in a results table. Remember, you don't have to show FSA for everything. You might show an FSA for different types of garden beds. You might have found that you like one particular type of garden bed, and you're going to say, I picked this style of garden bed and I did 8 of them. So you would go the area for 1, and then you would say FSA area for however many you had. So that's what we're looking for here, because remember, you want to be important with the show the important working out, but you want to be logical and systematic. In a table and give like one example, that would be better for you. So you might have your design of your garden bed, you're going to have your calculations, you might have your results, you would explain with your working out, so explanation. So things that you need to consider when you're doing this. If you have a figure, if you have figures and tables, they need to be labeled. So you have captions. They also need to be referred to. So you can't just put something in text, like you can't just plonk it in. So something like this. The base included several garden beds and pathway, figure 1, attached. So it might not necessarily be in with my task sheet on the sheet, but I can have it on the back there. Make sure that you can put your name on things so that if it does get lost, we can get it back to you. So then you would have that as your figure 1. So you might have like figure 1, design of garden bed area, design of vegetable garden. Then you might have something like this. The area of the rectangular garden beds was calculated as the example. So there's my example. This process was followed by for other rectangular shapes and shaped beds. See table 1. So, and I would have like bed 1, and I would label them on my sheet so I know like where they are. So you might label all of these 1, 2, 3, 4, whatever number of beds, and then you could have like the area for each one of those. So area is bed 1 was 4 times 3 and then 12 meters. You might have bed 2, and you might have 3 and 1, 3 meters squared. You might even have like you could put another column in here, and that might be like quantity, and that'll just Excel. You might be able to get a way to help you do your calculations. So that is something that you would be looking at there. Now, I feel like that's covering most of those things. So work through logically. That's why I was saying how important it was to use your plan. So if you have your plan, copy it over, and then that way you can go through each step and explain what you're doing when you do those things. Now, to look at your solve, there are a couple of aspects that you are looking at here. I'm just going to make that a wee bit bigger if I can. Maybe not today. So here we are. Be efficient use of technology. You want to be able to make sure that you're doing things like this so that you can set it up so you don't have to keep doing calculations. Be a calculator. Efficient is looking at things like Excel or GeoGebra or other software that can help. Superficial means that you are not using technology all that much. So you might only use your calculator and graph paper, but you don't use your ruler properly. So that's what we might be considering there. Okay, this is the part where use of getting these guys sorted. So I'm going to look at the application of mathematical concepts relevant to the task. Simple application of concepts would be constructing your drawing on graph paper. Application of mathematical concepts, techniques relevant to the task. So see, the idea is this is very simplistic application. So drawing your garden bed design, or maybe doing 1 or 2 calculations. Application of the concepts would be like doing your area, perimeter, and volume calculations. And discerning just means with good judgment, application of mathematical concepts and techniques relevant to task. So that means that you're looking for things that you're making good judgment on, like what you would use. So things like solving the problem, you might use the appropriate scale. So I've given you the scale, but you've made sure that you're using that appropriately throughout your whole sheet. So you're not just going, oh yeah, 1 centimeter just because it's easy, or that's 5 centimeters and it's easy. There's implications for that. You don't really want a 5 meter long garden bed unless you've got all that space. So that's what we're looking for there, and making sure that they're, again, relevant to the task. And then the last one that we've got on that box is use of complex procedures to reach an accurate solution. Use of complex procedures to reach a reasonable solution, and use of simple procedures. So simple procedures would be like things where you are just working towards, you might do a couple of the calculations, you might do perimeter, area, and volume, but you don't do your total. So this person here is probably going to be doing not only their area, perimeter, and volume calculations, but like total calculations. They might also be doing like percentage cover. The other thing, or anything else that they could use as data collection. The other one that they would also be doing is that you would have in this section, to reach that complex procedure, you will need to have composite shapes, triangles, and your scales. So considering your scales, your composite shapes, and your triangles with that one. You might even include curved areas. But if you're unsure how to do them, either come and ask or go and do some research. Curved areas, also like percentage cover. So complex just means that you are doing multi-step processes that require you to, and if you make a mistake, like if you're trying for that and you make a couple of errors, then that's when you come into this bracket here. And if you're not having a go at those complex procedures like composite shapes, finding total area of things, then you're going to be here. So that is where we stand with your solve section. So making sure figures and tables are labeled, you've got everything that you are doing to work towards the solution, including explanations of what you are doing so that it makes sense, and it's also showing a logical procession. Okay, that's that one. Almost there. Home stretch. Thanks.